So the question we're looking at here says 50 cm cube of hydrogen was flowed with 20 cm cube of oxygen at 100 degrees Celsius and 1 atmosphere. Calculate the volume of the total residual gases. Now we have a balanced chemical equation. So if you look at this question, we find out that what is happening here is happening at 100 degrees Celsius and 1 atmosphere. Here we are asked to do what calculate the volume of the remaining gases or residual gases. That is the gas that will remain at the end of this chemical reaction. The gas that will remain at the chemical reaction is the gas that will not react and the product. Now, because why is the product involved? Because this from the balance equation, we have this gas, this as gas. The water here we have is gas because at 100 degrees Celsius and 1 atmosphere, water exists as what? Gas. That is why we consider it as gas. Now I want to do this because of the question I received in the comment section of the very video that has to do with this. That is a question that has to do with 2022 NECO exam. That's one of the questions they asked in 2022 NECO. Somebody, one of my audience asked a question that has to do with this, and she did not, or he did not understand what I really and so I want to go through it again to really help this person to understand. If you're watching this video, watch it carefully and go back to the previous one, compare the whole thing, and find out that that will help you so much. So that's why I'm doing this once again. So look at this, and when we solve this, according to Lussac, we know that Lussac said that when gases react, they combine in a simple ratio with one another and the products. Now, the simple ratio here, he made us understand that also this mole ratio, the mole ratio or the stoichiometric ratio here, stand for or can also be considered as their what volume. That is why in this reaction, based on the ratio, the ratio of their volumes here is what 2 cm, and this one is 2 cm, and this other one is also to give us 2 cm of steam based on what we have. So if it is going to give us 2 cm of steam, then what we have, looking at this, the first thing you need to know here is the one that is reacting in excess. Because the one that is reacting in excess, and you know the one that is reacting in excess and the one that is reacting that is not enough or limiting reagents. This is, if you look at this very well, we find out that from this, if we are to combine, if we are to burn the whole of this hydrogen, if you are to burn all of them, you find out that from the balance equation, the ratio of their combination, you find out that more um, more more oxygen will be required. More oxygen will be required, which means this 50 cm cube, this 50 cm cube will require something like 25 from here. Since this is 1, here is 2, that means oxygen will always react with half of hydrogen that you have. That is to say, if this one will react now, all of them will react completely. What we need here is 25. Half of what we have, half of the hydrogen we have will react, half of hydrogen we have will react with, sorry, if the whole of hydrogen will combine, it means that it will need half of hydrogen, half of oxygen of each volume. This volume now to here is 1. Then if it's 50 in this case, what we have here will be 25, which is half of the volume of hydrogen, which means hydrogen is the one reacting in excess, and this other one, oxygen, is the what limiting reagent. Because if you look at this oxygen, if oxygen will combine, let's find out what this oxygen will produce. If total of this one will be consumed in this reaction, we will have like, let's say from this balance equation, we know that 1 cm cube, 1 cm cube of oxygen will react with 2 cm cube of hydrogen. Then if we have 20 cm cube of oxygen, it will give us 2 times 20, that will give us 40 cm cube. This 40 cm cube means that in this reaction, only 40 of this volume will be consumed completely for this oxygen to go out of to be used up. For the oxygen to be used up, 40 cm cube of this will be consumed. If 40 cm cube will be consumed, that means we have 50 out of this 50, 50 minus 40, we have 10 cm cube remaining of the what? Hydrogen. The hydrogen is remaining 10 cm cube because this 10 cm cube will not have enough oxygen to combine with it. So this is because the question said that total residual gases, that means one of the residual gas or the remaining gases we have there should be what? 10C, and one of them should be what? Or 10 cm. Let's just leave it there. So the next one we have, now if you look at this chemical equation again, if you look at this again, what will you see? You notice that if we have 1 cm cube of anytime 1 cm cube of oxygen combined with 2 cm cube of hydrogen, it will give us 2 cm cube of what? Water vapor. According to this, based on this altogether, it will give us vapor because if the temperature is lower than this, it will be water. So it will not be part of the residual gases or the resulting gases or the remaining gases. Now, because it's still in this form, the 100 degrees Celsius and 1 atmosphere, it simply means that it's still a gas. So because it's still a gas, a vapor, since it's a vapor is a gas, so if you go, it means that we need to find this part of the gases that will remain part of the gases that will remain. So now what do we have here? So if it's so, looking at this, if we have 1 cm cube of what? Oxygen combined with excess volume of hydrogen, what we have as water still? Vapor. The vapor, the vapor will then, or water vapor, let me use water vapor. Water vapor will be equal to the water vapor will be what? 2 cm cube. That's 2 cm cube because of this. So what we mean is that since we have 20 here, our 20 cm cube, 20 cm cube of oxygen will then give us what are we going to get? We have 2 over water times what? 20. That will give us what? 40 cm cube. 40 cm cube. Now you see at this temperature, since we said it's what? It's still what? Steam. Then 40 cm cube is part of the residual gas. So now what it means now to get the residual gas, total residual gases now will then be this remaining of hydrogen, which is 10, plus the steam, which is 4. That will give us 50 cm cube. So thank you so much for being part of this class, and I encourage you to share, like, and subscribe if you have not. And now if you still have any question, you can still drop it in the comment section. And I also encourage you to watch the playlist I created for this, which is a Lusac's law of combination. Lusac's law of combination of gases. I have a playlist there that will help you to see some other questions that can help you understand it very well. Thank you so much for being part of that. Thank you for the comment. I'm so happy about it. Thank you.